So here we're going to find the slope of different functions. So here's your page that I took a picture of your lab. So I'm just going to do a few in each section. So let's start with just a simple table. We know on this table that we have a pattern of y's, and we have a pattern of x's. We know that slope is rise over run. That's important. So the rise is the difference of the x's, the y's, and the run is the difference of the x's. So here we have our pattern of y's, and it looks like I'm going from -13 to -1 to 11 and so forth, so I'm getting larger, so I'm adding, and the difference between them is +12. Then we have our pattern of our x's, and here I'm getting larger as well, so going from 23 to 20 to 17 to 14, the difference of +3. So our rise is our y coordinates, 12. Our run is our x coordinates, 3. And then 12 over 3 is 4. So our slope is 4. Next problem. I have another table. So, again, let's do the same thing. We know slope is rise over run. So in this case, I have my pattern of y's. I'm going down, so that means I'm subtracting, and the difference between all of them is -3. Okay, I have my difference of x's, and in here it looks like I'm getting larger, but we know on a number line, the smaller the negative, the larger the negative, the smaller it is. So I'm actually subtracting here. I'm going to the left on a number line. So I'm actually subtracting 1 each time. So our rise is our difference of our y's right there. And our run is our difference of our x's right there. And then you have to deal with your integers correctly. Negative divided by negative is a positive. 3 divided by 1 is 3. So our slope is 3. Okay, so let's look at the equations. We know that if we put an equation into slope-intercept form, y equals mx plus b, that m is our slope. The number in front of the x is our slope, but only if it's in slope-intercept form. So on the first one right here, that's y equals mx plus or minus b. So the 2 in front of the x then obviously is our slope. But then like in class today, we have this equation. That's not in slope-intercept form. So we have to manipulate it to get the y by itself. So first thing I'm going to do is do my same change opposite. That -3 needs to be moved, so I'm going to do a +3 on both sides. So I'm left with the y by itself after canceling equals x plus 7. So now that is in slope-intercept form. And what's the number in front of the x? Well, there isn't one, but we know that a 1 could be there. So in this case, our slope is 1. Okay, next one. -3x plus y equals 5. Again, that is not in slope-intercept form. So I have to get the y by itself. So in this case, I got to get rid of the -3x. The opposite of -3x is +3x. So I'll do that on both sides. Okay, the -3x and the +3x will cancel. And I'll be left with the y equals +3x and then plus that 5. So now it's in slope-intercept form. So we know the number in front of the x has to be our slope. The number is the 3. So for this equation, m is 3. The next two equations are special. We can't manipulate them because they already have the letter by themselves. But we know that if y equals 8, that means every coordinate has y as 8. So if I were to do just a quick sketch of a graph, okay, and I were to go up to 8 for all the y's, let's say up here is 8, and put like 1, 8, 3, 8, 6, 8, whatever it might be, -4, 8, that's what I would have. And then of course, if I were to then connect those points, it would give me a line that is horizontal. And if that's the case, we know from our notes that that slope is 0. If I were to do the same thing for x equals a number, we know that the points would be going vertically, up and down. So we know in that case our slope is undefined. And the last one is in slope-intercept form, so I think you can find that one. Okay, next one. Our function is in a table form. So we know from our notes that we're going to find the slope by using a slope triangle. So I find 2 points on the graph that I can identify. So here's one right there, and here's one right there. We wouldn't pick that because we don't know where it is between the 1 and the 2, or the 0 and the 1. So now my slope triangle would be rise, and then run again. So I'm going to go up here for my rise, over here for my run, and then I'm going to just measure it. So that's up 1, up 2. So I'm going up 2, and over to the right 1, which is positive. So our rise is 2, our run is 1, 2 over 1 is 2. So that's easy when you have a graph. Just use your slope triangle. All right. And now the new thing we learned today is finding slope when I have 2 points. So first of all, you could graph these points on a, on a coordinate plane, and then you could use your slope triangle. But that's an extra step. So instead we learned that we have the slope formula. Okay, you have to know this in order to use it. Okay, we know the slope formula is the difference of our y's over the difference of our x's, because it's rise over run, and we know our y's make the rise, our x's make the run. So we're going to do y minus y over x minus x. You just have to remember to put the y's on top and the x's on the bottom, and you have to go in order. So I always like to go left to right. So like this one. Let's do this one here because I did the other ones in class. So my first y is 5. My second y is 11. So I'm just substituting the y coordinates in for the y's. Now I'll do the same for the x's. My first x coordinate is -1 minus my second x coordinate is +1. Do your same change opposite and calculate. 5 plus -11 is -6. -1 plus -1 is -2. A negative over a negative is a positive, and then 6 divided by 2 is 3, so your slope is 3. Now, if you don't like using the formula, we've learned to find slope in a table, right? So let's just create a table and do it on that. So there's my table. Here's my x coordinates or input domain. Here's my y coordinates, output or range. So let's do this one right here. So let's put these on the function table. So I have 8, 5. So there'd be 8, there'd be 5. Then 8, 3. Well, remember from earlier on our function tables, when we have the same x's all the time, that's a special equation. That's going to be x equals to 8. Now remember, when you have your equations and you have an x equal or y equals, it's going to have a special slope. What kind of line would this give you? Well, if every point had 8 for its x coordinate, it would give you a vertical line. So what's the slope of a vertical line? Undefined, isn't it? So that would be undefined. So let's do a different one. Let's do this one right up here. So here's our little table. We have our x input, our y outputs. So I have 0, 7 for my first ordered pair, and I have 1, 9 for my second ordered pair. Now just find the pattern. So I'm going from 7 to 9, so that's +2. I'm going from 0, 1, so that's +1. We know that slope is rise over run. So our rise is 2, and our run is 1. And we know 2 over 1 is 2. So I can substitute these points into a table if that makes it easier. So you have to be able to find slope for all of these different types of functions. So this is what your quiz will be on. All right, good luck.